All right, you guys, we're back with proving theorems about parallelograms. So, in our last slide, we learned quite a bit. It's a quad. Opposite sides are equal. Opposite angles are equal. We learned that opposite sides are parallel. Slopes are the same. Opposite sides are slopes are the same. So this is slide 11. Looks like I got a GeoGebra to open up. Is it going to give me a parallelogram? Same parallelogram. Okay. Same parallelogram. All right, so let's see what we got to do here. We got to draw the diagonals of AC and BD on the parallelogram. Okay. So AC, make this a little bit bigger. Oops, I didn't mean to do that. No. Clicked on the wrong thing. Let me try again. Alright, so I need to draw my parallelogram. So I'm going to click on segment. I'm going to click on, what happened there? A to C and D to B. So there are my diagonals. Okay. Make a point where the diagonals intersect and label it E. So come over here to point. Put a point right there where they cross each other. It's going to be labeled E. Measure and record the lengths of the 4 line segments you just created. Okay, I know where they're going with this. All right. So let's see. I need to find the distance or length. I'm going to click on B then E, C then E, A then E, and D and E. They're going to be equal to each other. Look at that. BE and DE are equal. AE and CE are equal to each other. So I need to label those, huh? All right, so I've got 2.5s and 1.5s. All right, so let's see. AE, that was a 2.5. And BE was a 1.5. CE was a 2.5. And DE is a 1.5. All right, so measure equal the lengths. All right, I just got that. That's all I got to do. So there's question 1. All right, so something new we've learned. Diagonals bisect each other. In other words, they cut each other in half. The 2 parts are equal. Based on your measurements in question 1, what's the relationship between the diagonals of the parallelograms? Ha! Just answered it. The diagonals bisect each other. Yeah, it divides it in half. That's the same as the word bisect. So that makes me a midpoint there, which is point E. Awesome. So question 3. Move vertices A, B, and C to modify the original parallelogram. As you change the parallelogram, notice what happens to the diagonals. I'll tell you right now, they're going to remain the same. But I'll move them. Show you. So come over here and click move. And I'll move B, and I'll move A, and I'll move C. And they still remain equal to each other. 3.72 and 1.46. So the relationship does not change. They are going to remain equal to each other. No change in the relationship. Bisect. Now they say the word bisect. Okay. Question 4. Explain how you can prove your observation in question 2 using a traditional proof. Ugh. All right, you don't need to develop the steps of the proof. Simply just describe an approach that you would use. Which theorems might appear in your proof. Use 2 diagonals of the parallelogram to assist you in describing your approach. Oh gosh. Okay, so let's see. What have I got here? I've got 4 triangles. And we already know opposite sides are equal to each other. So we've got definitely 2 sides. Well, we got 2 sides. We got side of the top and bottom. Haha. I can do that. We got a side, side, side for the left and the right triangle. I'm not exactly sure if that's what they were asking, but that's what I'm seeing right now. So if I look at the 4 triangles, there are 4 triangles. The top and bottom triangles are congruent by side, side, side. The left and right triangles are congruent by side, side, side. Okay. 4 triangles. Okay, I'm in the same direction. Let's see, congruent, corresponding. All right, so they just went with the corresponding stuff, but they went to a little bit more detail than I did. All right, question 5. Now go into diagonals of parallelograms. All right, so we got a whole brand new geometry here, y'all. That's new. It's never done that before. Oh, okay. I'm looking at line segments. I have no clue what to do. All right, so you will see 2 line segments, AC and BD, marked with their midpoints, E and F. Verify that E and F divide the line segments equally by measuring and recording the lengths of the 4 line segments. Okay, so I need to come up here and go to distance or length. So I'm going to find AE first. It's a 4. I'm going to find EC. That's a 4. BF, 2.24. FD, 2.24. Okay, I'm not really sure where they're going with this, but that's what they asked me to do, so that's what I've got. All right, so the first one was AE, and it was a 4. And the second one was EC, and it was also a 4. Then I had what, BF and FD. So BF, FD, and those were both 2.24. 2.24. Goodness. Okay. There's the equivalence of the 4 line segments. You see, okay, so that's all they asked for. So there's question 5. All right, question 6. Now I guess I get to see where they were going with that. Move AC and BD so that their midpoints coincide. Huh. Okay, so I'm going to come over here and click move. And then coincide, I need them to lay on top of each other. Oh, look at that. Okay. Okay, I see where they're going with this. And we're probably going to end up connecting these to make a parallelogram. So they're proving that if the diagonals have been bisected, then we got a parallelogram. Okay, I see where they're going with this. All right, then draw a parallelogram through points A, B, C, and D to form the quadrilateral. Ha! What did I tell you? All right, so I'm going to come back over here to segment. I'm going to connect A to B, B to C, C to D, D back to A. All right, now we got to measure and record the slope of each side of the quadrilateral. So basically all we're doing is proving that it's a parallelogram by looking at their slopes. So my 4 sides were AB, BC, CD, and DA. AB, BC, CD, DA. And I need to find their slope. So in case you've forgotten where the slope is, it's underneath this angle icon. Select slope. So it looks like AB is, I think that's a 0.67. BC is negative 0.4. Yeah, it is. It's a 0.67. It's a positive 0.67. And I guess AD is going to be negative 0.4. Yeah. So this is a parallelogram because your opposite sides are in fact parallel to each other. So let's put that in. So let's see. AB was 0.67. So was CD, because that was the opposite side. BC was a negative 0.4. And so was DA because opposite sides are parallel. So I got to do anything else? Nope, that's it. Hit submit. All right. Question 7. Based on your slope measurements in question 6, what you conclude? Man, am I good at this or what? Half the time I just explain verbally what they're going to ask next. This is a parallelogram. Look, it's a parallelogram. Can I call it or what? I guess it's what happens after you teach geometry for about 20 years. All right, suppose that you repeated question 5 and 6 using 2 line segments of your choice. The line segments could be any length and in any orientation as long as the midpoints were marked correctly and coincide with each other. Would you reach the same conclusion that you reached in question 7? How does your conclusion relate to the diagonals of the parallelogram? Well, yeah, of course you would get the exact same thing. Yes. What's your conclusion relate to the diagonals? The diagonals bisect each other. Yeah, you'd reach the same conclusion. Okay. It's a parallelogram. Okay. Oh, okay. Hey, self-eval. Whoop, whoop. I'm always a 5 because I rock some geometry. All right, you guys. So this was slide 11. We've learned quite a bit in this tutorial. That opposite sides are equal. Opposite angles are equal. In this one in particular, that the diagonals bisect each other. All right, we're only on slide 11, so I bet I've got another one coming up. See you then.